Hello and welcome back. In this video we'll continue looking at section 10.2 on regression lines, and we'll start to use regression lines to make predictions for our data. We pretend that we've looked at the data, we've seen that it maybe is somewhat linearly correlated, and we've drawn a regression line. If that regression line is a good fit, we can use that regression line, or I should say the equation for the regression line, to make a prediction, to predict the data value. Remember that the regression line is going to be something like y is equal to b naught plus b1 times x. So if you know x, you can plug it into the equation. You've got your y, and we can predict it. If the regression line is not a good fit, then we don't really want to use it. Here, the best prediction that we can use for data that we don't know much about is just going to be the mean. If I had to predict what is the value of y, the mean of our sample is always going to be a pretty good predictor. One thing to keep in mind is that making predictions that go beyond the scope of the data is very ill-advised. So for instance, maybe we're looking at the last 30 years of obesity rates in the US, and we could use this to make predictions about the next couple of years. But say 100 years from now, 1,000 years from now, the data over the last 30 years probably isn't going to be relevant in that long. So it's important to keep in mind what sort of ranges of data values are we talking about, and going too far either into the future or too far beyond any of these values won't lead to very good predictions in general. So let's see how we can use regression lines and means to make predictions. In particular, how do we tell if a regression line is a good fit or not? We just use p-values. And these are the two things that we'll have to remember. If the p-value is less than the significance level, that means the regression line is a good fit, and we should use that. If our p-value is bigger than the significance level, well, then we can't really trust our regression line. So we'll just keep this in mind, as we'll look at this first example. So we have the heights and weights of 100 men are measured. We'll have x as the height and y as the weight. So we find a bunch of things. So let's go through this. X bar is going to be the mean height, and that's 167 and about a half a centimeter. Okay, so that's how tall on average these men were. Y bar is going to be the mean weight, and that's going to be 81.5 kilos. So again, that's just the mean weight of all 100 men. R here is 0.029. So this is the linear correlation coefficient. The closer R is to 1 or to -1, the more linearly correlated the data will be. So this doesn't seem all that linearly correlated, but we found, but the p-value here for this data is really small. Okay, so it means that our line is probably a good fit, and here is the equation of our line. Negative 106 plus 1.03 times x. So we want to find the predicted weight of a man who is 165 centimeters tall, and we'll use an alpha is equal to 0.01 significance level. So coming back to our test here, if the p-value is less than the significance level or the p-value is greater than the significance level, we have two things going on. So here, the p-value is less than alpha. So let's write that down so we remember. We have the p-value. Maybe I should make that there. Is less than alpha. So we use the regression line. Cool. So in using this, we can just plug this in and use it. So y bar is going to be our predicted value for the weight, and that's just going to be negative 106 plus 1.03 times x. X is the height, and what we're predicting is the weight for a man who's 165 centimeters tall. And if we plug this in and do the math, we get that this is going to be 63.95 kilograms. So the only thing that we need is the fact that our p-value is less than alpha, so we use our equation. Okay. In the next example, we're looking at IQ scores for pairs of siblings. So we'll say that X is going to be the IQ of the older sibling and Y be the younger sibling. So we have the average IQ for the older siblings is 1.05, 0.07. The average IQ for the younger sibling is 1.04.05. R is 0.923, so it seems pretty linearly correlated. And the p-value is 0.126. So that's pretty big for a p-value. And here is our regression line, our line of best fit. And we want to find the predicted IQ of the younger sibling if the older sibling has an IQ of 107. Okay, and we'll use an alpha is equal to 0.05 significance level. So again, we want to compare the p-value to alpha. But here, our p-value is in fact greater than alpha. So that means that our line is not going to be a good fit. So we don't use the regression line. Oops. Okay, so if we can't use a regression line, does that mean that we're done? We're sunk? Nope. If we just had to make a prediction on what the IQ of a younger sibling is, we'll just use the average in our data sample. So the predicted value, which is going to be y hat, the only prediction that we can make is probably going to be pretty close to the mean, to our average IQ. So there is our prediction. If we can't make it using the regression line, we'll just use the mean. So the one thing that we haven't really talked about is how to find this p-value. And essentially, I just want to show you where we'll find it in StatCrunch. So listed below, as in StatCrunch, as I'll show you in a second, are some chest sizes and weights for bears that have been tagged and measured. So we want to use a significance level of 0.05 to predict the weight of a bear with a chest size of 40 inches. So let's do this. Let's come over to StatCrunch. So we've got 6 bears were tagged and measured, and we have the chest size and the weights all here. So to start with, I think it's nice to just look at a scatter plot to sort of visualize the data. So we'll look at the chest size and the weight. Again, we are given the chest size and we want to determine the weight. This means that the chest size should be the independent variable, and the weight depends on the chest size. So the weight should be the dependent variable. So weight is y. Just for our scatter plot, we don't need to do anything else. And when we look at it, yeah, this looks pretty linear. So we're good to go. We can do linear regression. So if we come to stat and we come down to regression, yeah, we want to do simple linear regression. Again, x, our independent variable, should be chest size, is the one that we're using to predict the dependent variable, which is y. Again, hypothesis test, confidence intervals, this is not necessarily what we're doing right now, although we'll find the p-value for that. The prediction of y, so we want we want to predict the weight of a bear with a chest size of 40 inches. And the significance level is going to be 0.95. Sorry, the significance level is 0.05, so the confidence levels should be 0.95. I also want to do a fitted line plot with this, just so that we can look at this. And I'm not going to touch anything else, and we'll just hit compute. So let's look. So first of all, let's look at what our line is here, and we can see that yep, this is our line. It's going through the data values. It looks to be pretty good. Here is our equation that pops out. The predicted weight will be equal to negative 330 plus 16.3 times the chest size. Now, the p-value that we want for our model is going to be 0.0003. And if we compare the p-value to the significance level that we wanted, which is 0.05, our p-value is a lot less than that. So we want to use the our formula, our regression equation, to make this prediction. And the nice thing is that down here, it will do this for us. It will plug in the value 40 into this equation to come up with a predicted y value of 322. Note that it also constructs some confidence intervals, but we're just going to ignore that. This is our predicted y value right here. So when we come back, using our 0.05 significance level, that the p-value is much less than this, so we get to use our regression equation, and ultimately we're told that it will be 322 pounds. And all of this information is here. Again, just to run through this really quickly, the equation, the regression equation, the p-value will be found next to model. So our model, our regression model, will have the p-value there. And if everything goes according to plan and we can use our model because the p-value is less than alpha, there is our predicted value.